you now have information to finish the calculations. You'll notice that there are certain areas that are highlighted and that having matching highlight areas below. That just shows where the calculations for that value should go. If there's no box below for calculations, you can just write the calculation in the blank. For example, delta T represents T final minus T initial. If you do this calculation and you end up with a negative number, that's okay. Or if you do the calculation and you end up with a positive number, that's okay. Make sure that you do include, if it's negative, make sure that you include the negative with that value. At some point in this lab, when you calculate delta T, it will turn out to be negative. So since there is no calculations box for T final minus T initial, just write it in the chart with the answer circled. This calculation is most likely going to be what affects your significant figures. So if your highest value, your final value, was 30.1 and your initial value was 23.1, remember with the addition rules, you're going to subtract and you're going to get 6.0 and you keep it rounded to this position, the 10th position. Notice that this has 2 sig figs. So you could have that situation, but you also could have a situation where you have 3 sig figs or 1 sig fig. It just depends on how these numbers are subtracted. So pay very, very close attention to your sig figs when you are doing your temperature changes. Make sure you know where to get the final values for both the delta T of water and the delta T of final of the metal. So your final temperature of your metal is right here. And by the way, this is your initial temperature of the metal. The final temperature of the water is also this value. And here's your initial temperature of the water. This is just like in class you've been learning. It's mass times specific heat of water times delta T. This can be represented with a C or an S. It's both ways. And although this is the copper column, don't let this confuse you. You are currently determining the Q for water. This is your mass. I want to make sure that you can see the areas you're supposed to be getting this information from. So this is your mass, and again, this is all information about water. So this right here, your mass of water, is going to be here. Then your delta T of water is going to be right here. Don't forget, and this is only be said once in this lab, your CW of water is 4.184 joules per gram times degrees Celsius, both of those being the units on the bottom. That value will be used over and over and over. It's a constant, and it's what goes here. Once you fill this value out, you're going to use different numbers, but the same equation for the C. This time you're going to say Q of copper, or the metal, is equal to M times C times delta T. And again, this is for the metal, this is for the copper. And if you prefer to call it M, that's fine. What we want you to solve for this time is this value. So you can rearrange that now or later. Just to point out, we do know the Q of copper value right here, it actually is this, and it's going to be in this section of the chart. If you're confused on how to fill this little section out, all it is you put the number you get here, you repeat the number, and you just change the sign. So if this were negative, then this would be positive. Or if this were positive, then this would be negative. The mass of the metal was given up here, and the change of temperature of the metal is calculated right here. So see, you're just missing the one variable. For percent error, you've done this multiple times now. This is the absolute value of the true minus the experimental value divided by the true value times 100%. The true value is the value that we give you. Remember that the sig figs are almost always governed by this top term right up here, and it works in a similar manner to these. This is fantastic practice for class.